I'm really happy to be here. It's my first time at PyCon, and I was already told that it's, well, a big conference in the sense that we have just listened. There are 1,700 attendees, but I was told that it's still familiar, so I'm quite excited what's expecting me the next 3 days. But I definitely know what is expecting you in the next 40 minutes. So the title of this talk doesn't leave space for speculations. Wow, they're just coming in and in. Cool. Wow. It's getting full. No, never start on time. Wow. It's getting really full. Yeah. Wow. So welcome again to everybody who joined us. I'm happy that this year of the today's talk fascinates you because you've chosen the way to this room. And well, the title of the talk is From Notebook to Pipeline in No Time with LineaPy. So I present you a way to convert a notebook to a pipeline like Apache Airflow, Ray, Argo, DVC. But I'll not do it by hands, not by fair means. No, I'll use a very new tool, an open source tool, LineaPy, because it saves you time and nerves. For me, this is a relevant job because I have to do it a lot of times. At least you're sitting here, so it seems to be also relevant for you. But in case you're not convinced why you should convert a notebook into a pipeline, let's just draw the big picture. So let us assume we're all data scientists, or well, at least we get a project where we do something with data and AI. And such a project normally starts with doing analysis on the data, doing some prototyping. We are looking for a model, for example, machine learning model, which works, which does the trick. And we got the goal that in the end, we provide a service, a microservice, or we have to integrate it in a product. And from going from the left to the right, you cross a line. And the line separates the field of development from the field of operations. So it separates dev from ops, or when you do machine learning, ML ops. So what's the characteristics of these fields? In development, you're looking for iterations. You're looking for feedback. We don't write code, well, in a complete sense, no. We are implementing some lines. We are writing a test. We are starting the compiler. We get feedback. Does it work? Does it not work? So on the development side, we just try to get things working. And on the MLOps side, or ops side, the focus switches. So we want to keep things working. We don't want that something changes without our intention. And the last 3 years, tools have emerged for those two sides. So a classic choice for the development side are Jupyter Notebooks. Jupyter Notebooks are great for doing experiments. We get immediate feedbacks. We can do a lot of things without doing other things we did before, because we're just using variables in the memory. And Jupyter Notebooks are great, but they are also bad, because they're not reproducible. So when you've ever tried to share a Jupyter Notebook, you know what I mean. So, on the other side, there are pipelines. Pipelines like Apache Airflow, DVC, Argo, and Kubeflow. And it makes sense to use pipelines, because pipelines are reproducible. You're fixing things there. You can check them in your Git. You track the code, and when you track it, you can do continuous machine learning, because you get metrics out of your CI/CD You can do continuous improvements. Well, when there are so many benefits in pipelines, so let's transform our notebook into a pipeline. Can't be so hard, or? Well, when you think about your last experimentations in a Jupyter Notebook, it's not, because a Jupyter Notebook is normally a mess. So it all starts, for example, with package management. Who does fix the version when he does a pip install? Nobody. You just do pip install package. So that's where it starts. You're completely dependent on what the Jupyter Notebook at the time finds in your package management system, and you rely on the underlying Jupyter kernel. You probably don't know about it. First problem in reproduction. So, and the second problem is that you're playing with variables. So you just use variables, you reuse them, you transform them, you just do a lot of things. You delete cells, you edit cells, you depend on variables which were generated from deleted cells. So, and that's only the first thing. So the second thing is that your order of your cells does not reflect the order of execution. And there's no history about what you did in the past. So when you found a model, you rely on your brain what you did until the model worked. And perhaps you're lost in reproducing these steps. But there's a solution. You can use LineaPy for all this. And it does a lot of stuff for you and saves your lives in case. Okay. And to see how this works, we'll look on a simple example. But before, we prepare our notebook. So if you want to give superpowers to your notebook, you have to do these 3 lines before. First, you do a pip install LineaPy, and you don't start fixing the version because you never did. Okay, then you load LineaPy as extension. And that's where the superpower begins, because now LineaPy watches the memory for you. It looks how you arrive to the variable. What did you do in the memory? It looks about the ancestors of the memory, of the variables. That's where the word comes from, lineage. And last but not least, you import LineaPy, because we want to use some methods from the package. Okay, so far so good. Fasten your seatbelts. A simple example. So we say variable A equals 1, variable B equals 2. I'm allowed to use these variables because I studied math, so I get the license to use such variables. And in the third line, we sum up those 2 variables. C equals A plus B, C equals 3, just to point. And the first thing LineaPy gives us is a method called save. We save the variable C as artifact named C. And now comes a magic part. We can now say, okay, let me just print the code, what happened. How did I came to this artifact? And LineaPy now connects all the things together, and it says, okay, in order to reach C, you've done the definition of A, the definition of B, and afterwards you summed it up. And this even works when you've deleted the cell before you did the artifact save. Because LineaPy doesn't watch the cells, it watches the memory, what happens there inside. That's pretty cool, I think. So because when you get to the point your model worked, you can just say, okay, I saved the code which delivered me this code, this model. Wow. So let's push the limits a bit. We now do a small import. We import NumPy, but just to do a simple multiplication as complex as possible. So we define a parameter, my parameter equals 3, and then we multiply c by the parameter using NumPy. Okay. The result is that d equals 9. So far, so good. And we do the same thing again. We define an artifact and print out the code. So I've missed to copy the print command there, but I just want to show you the result. I hope you trust me that this is the result, in fact. And LineaPy also tracks the imports. So you also get the information on what imports you rely on. And this will be also important later to build the pipeline. And we are just one step before building a pipeline. So that's a feature we are all waiting for. Let's see. LineaPy has another method. Not only the save method, but also the toPipeline method. And we are now saying LineaPy, okay, take the two artifacts, C and D, and well, build a pipeline for me. So the framework should be, in my case, DVC, because I like DVC pipelines. We'll see later on why. But it could also be a Kubeflow pipeline, Apache Airflow pipeline, Argo, or even Ray. I just looked inside the code yesterday and I saw there's also a Ray plugin inside. Okay, and to make things a bit more complicated, we say that an input parameter of the pipeline should be my parameter. That's perhaps important when you do machine learning and you find a good solution for a model, but you want to do hyperparameter optimization. Then you can use the pipeline in order to just play around with the parameters. Okay, and then we just say, there's a pipeline name, my pipeline, output directory, cool, and let's see what's happening. Now, LineaPy does a lot of work for us. So it generates multiple files. So first of all, a module file, and we'll dive into these files later on. The module file contains the source code, which we also extracted before using the print command and the getCode method. And we get a requirements file. We'll see that what's inside there, but LineaPy tracks, in fact, all the packages which were used in the kernel. And then I get 4 DHE files related to the DVC pipeline. And last but not least, a Dockerfile. I like Dockerfiles. And we'll see later on why. Okay, but let's just go into the source code file. So this is an extraction of the myPipeline module file. And first of all, we see that it also imports NumPy there, because he's now aggregating all the artifact code. And he's generating code how you get to the artifact C. This reflects the output we saw before for artifact. And now, the next code, getD, is slightly different from the thing we saw before. Because LineaPy just analyzed the two artifacts and realized, oh, D relies on C. So we don't have to do here the recomputation of C, no, to C by fair means from the beginning, no. We'll use C, the return. And the user said my parameter is an input parameter. So before, the my parameter variable was defined as my parameter equals 3. But now it's an input parameter of the method. And we'll see later on in the DHE files why. And last but not least, it returns us D. So it's not only the code we got before when we printed it with the getCode method. LineaPy just put the things together in order to build a multi-stage pipeline as DVC supports. Who's in common with DVC pipelines? One person? Oh, it's a pity, you should use it. Use DVC pipelines. Now, one thing I like at DVC pipelines is that DVC keeps track on things you've already computed. So, and to get this trick, you have to define in this YAML how things are connected. So, LineaPy generated a multi-stage DVC pipeline for us because LineaPy realized that D relies on C. So, and here in this YAML, DVC YAML, we also have these multi-stages, and the first stage is to compute the variable C. And doing so, he calls a command. So every DVC YAML provides in every stage a command which has to be executed. And you tell DVC, okay, the stage relies on source code, of course. So for here, for example, the My Pipeline module where all the code is inside. And, well, it relies on, of course, the source code file you're executing. And on the other hand, you say, oh, okay, when you execute this, there's an output. And in our case, LineaPy saves the artifacts between the stages in Pickle files. So we come back to this later, why this can be a problem. But it's a common choice. And the next stage, on the stage D, you also have a little helper file, task D. We also refer on the dependencies on the source code file, pipeline, module, and task D. And now we say also that it depends on this Pickle file, which is the output of the first stage. So what is DVC doing now for you? DVC is tracking the checksums of the files. And when the checksum of these two files didn't change, DVC says, okay, then this output will also not change. And if the output didn't change, well, the stage D depends on, then I don't have to do the computation either, only when these two files are changed. Just think about machine learning. You get several stages, so perhaps loading the data, pre-processing the data, training the model, and doing some evaluation. When you change the evaluation, you don't want the first three stages to be changed or recomputed. You're saving a lot of energy because GPUs are using energy. Every computation needs energy. So your carbon footprint is reduced by using DVC. Just remember it. I think that's important to say because we have to take care about our Earth. So that's why I like DVC pipelines. And just to come back, what LineaPy is doing for us, it also will add a params section in the stage D. Why I say will, because I've seen that I left a bug. So I did this contribution which generates this code, and I have to fix this. But I'll do it when I drive from Berlin to Munich in the train. It's not a big deal. It's also perhaps a good point to mention how are these files generated. So LineaPy uses Ginger templates. And you're passing variables to these Ginger templates. And these Ginger templates are generating these files in a deterministic way. Okay. So this was the DVC YAML. And let's dive into the other DHE files. So this is the first helper file, the task C Python file. We import Pickle just to execute the code get C in order to get the variable C and to dump it in a Pickle object. And that's the first thing which can break your solution. who tried to pickle a TensorFlow model in this room? Yeah? Did it work? Yeah, it didn't work. Yeah, that's it. So you cannot pickle every object. For TensorFlow object, it's not TensorFlow models. It's not possible. There are other things you cannot pickle, and there are also things you shouldn't pickle because there are a more efficient way to save it. So if you want to store a pandas data frame, you want to perhaps use an HDF format or something like this. So this pickle attempt is a first shot, but it has to improve in future. But it's open source. If you have good ideas, so also the LineaPy community is discussing about this, how this can be done. Will there be an attribute in the notebook telling them, oh, don't use the pickle, use something else? So that's something we're thinking about. How to change it in future in order to reflect these edge cases, which are not edge cases, I think. So it's really important to fix this. Okay. But we got an artifact. And the artifact is loaded again in the next step. So this helper file, these task C, task D helper files are doing the job for you in storing objects and loading them back again. And last but not least, we see that LineaPy also now takes care about the input parameter. So it passes the input parameter to the method. And the parameter is in fact stored in the params YAML. And you can say, DVC, okay, here's my params YAML. When the parameter gets changed, it's connected to the stage and you have to recompute the stage. And that's how things are glued together. Okay. Any questions so far in the room? Yeah?
How was decided that there's a task C and a task D? Why wasn't it made in one task?
Oh, oh yeah, okay, I'll read this because, okay, so your name is? Aurel. Aurel asked, why did we separated the computation in different stages? That's a good point. Yeah, that's a good point. So, in fact, there's another argument in the two-pipeline method. You can say, okay, I want everything in one stage. So, for other frameworks also, so there are possibles to say, okay, I want not everything in one stage, but in multiple stages. So it depends on the plugin. So there's a DVC plugin, framework plugin. There's an Airflow framework plugin, Ray, Kubeflow, etc. And they all have different arguments on what to choose as a solution. So it's completely well. And this was also the first thing implemented by the LineaPy team to just put all together in a single stage. It's a fair choice because when you say when something changes, you have to do most probably everything. It's completely fine. So it was my choice to do this multi-stage attempt, and that's why I contributed to this multi-stage attempt to the library. So it's both possible. Yeah?
I have actually two questions. Can you also include type hints in the output? And the second question.
Oh.
Can you separate the scripts from the data? So, for example, that the data output is dumped into a subdirectory data.
Yeah. Your name is? Mark. Mark just said two questions. The first was related to type hints. So I think it should be possible. It will make the Ginger template more complex, but it should be possible, I think. It's a bit work. And the second thing is, could you also choose a directory, not single objects? Would also be some sort of work. So I don't know whether it's straightforward to implement, but that's also big plus point of the LineaPy team. So they're really community driven. So when I just said, oh, it's really a pity that you don't have DVC pipelines and multistage DVC pipelines, and they said, oh, okay, we don't have so much practice in doing DVC. Do you want to do the contribution? And I said, oh, yeah, why not? And they really helped me a lot. So for Andrew helped me a lot to implement the code, and I think just join the Slack community of LineaPy. They're really nice developers, and they're happy for feedback. And perhaps you're also doing the next contribution to LineaPy. Yeah?
Yeah, for instance, when you have a big data set, sometimes what you do is not just load it into memory, but just you are getting batches of it and randomly transforming it,
Mm-hmm.
with, I don't know, data loaders or pipers or whatever. How would that be translated to this logic? So you are, loading just batches of data, maybe in a random way with some seed or something like that. But anyways, it's kind of not always fixed, but sets of data,
So you mean you leave the notebook using somehow an individual implementations or individual tools outside, or are you calling a command, bash command or something like this?
No, for instance, I work mainly in computer vision, okay? So
Yeah.
a large database of images, okay? And what you do to train your model is that your model is loading parts of this database, transforming them with some randomness, and passing that to the model.
Okay, so I see. But then, yeah. Oh, okay. So I'm not used to that because I hear you. So just to repeat the question. So when you're doing computer vision, you're loading the model and you're doing some random stuff on it, or random stuff on the data. How is this randomness reflected in such a pipeline? So I think when you really want to do a pipeline out of it, you have to fix the randomness, but on the level of what randomness you're doing. So, for example, when I do a splitting, a pandas with sklearn and test data splitting, I set a seed. I think you have to set the seed in the code, because arbitrary randomness cannot be reflected by transforming it into a pipeline. Does this? Yeah?
That's not the question, but partially, because for the scenario where you don't load all your data at once, would that be compatible with?
We have to see, I think. Let's make a pair programming session afterwards. Oh, we also have some slides left, okay? Yeah?
Is there some considerable memory overhead or any computational issue with using LineaPy?
Oh, overhead. You mean when executing the cells?
Yes, when it watches the memory and remembers everything.
A good point. I didn't look for it. But I think it's really... the session chair really does a good job, so I have to repeat the question. So, is there an overhead, a computation overhead in doing so? So, do I slow down my computations? I don't know, but I don't think much. But I have to admit, I don't know. But join the Slack community, ask the question, because Doris and the other developers, they have really good insights there. Okay. I see we're really having good questions, but I got some slides, and I'll just go forward to the slides. So we are now through the DHE files. So we also mentioned what are the problems, what is future ways of contributing for solutions. And we are now coming to the Dockerfile and the package management. So when you look inside the Dockerfile, on the first line, there's a from Python 3.8, which is a very generic choice. So LineaPy just looked, what's your Python kernel? So what Python version did you choose? Okay, and then it says, okay, then I load the Python image. Then it copies the requirements file to the building process, the Docker, the image, and it does a pip install. And when we look inside the requirements file, LineaPy does not only say, oh, install NumPy. No, it also looks inside the kernel, what version is there. And that's cool, I think, because you don't have to do this. And there are now two things I think to say about the choice of a Dockerfile. I already said that I like Dockerfiles because I only trust Python interpreters in Dockerfile because they are really robust in the sense of reproducible. And that's the pro, but there's a small drawback in this Dockerfile. So if you want to do machine learning, you want to use GPUs. And when you do the generic choice from Python 3.0, you don't have GPU support, even if you installed your PyTorch CUDA libraries or something like this. But that's fine for me, because I did a lot of image building to get CUDA support on my hardware, and it's not easy. So at some point you still fail. So, for example, when there was the switch from CUDA version 10 to CUDA version 11, you had to install libraries from the 10th version and the 11th version just to get it running. And I think GPU is at the moment still too specific as to automate the thing. So if you would like to automate it, you have to say, oh, LineaPy, I got this hardware in A100. Oh no, I got an AMD hardware. Please look for proper images in combination with the packages I'm using. And no, I don't think that this... So if you're using GPUs, you know what's waiting for you, and I think it's the best to fix it yourself. Yeah. So from my point of view, this choice is really completely fine. And then there are some lines of code doing this DVC thing. Whoever tried to Dockerize a DVC, so we only got one person here inside. Did you Dockerize your DVC pipeline? Then you know these lines. You need to do this. You need a Git in it. You need a DVC in it. So this is boilerplate code, and I'm happy that I don't have to write boilerplate code. That's it. Okay. So far, so good. Now, I think LineaPy really saves you times and nerves to get from a notebook to a pipeline, because it does a lot of things in refactoring, saving your lives when you edited or deleted cells which you needed for your solution. And I have to say, I will never review a notebook again. Reviewing a notebook is it's a story for itself. So there are some solutions, but I'm not happy with them. And I've just discussed this with my team. So I think before I review a notebook again, I will transform it with LineaPy into a pipeline, because then I see the relevant code which made the model, and I can really just read the code which is important and not around. And I think this will save time for me, definitely. And the question is whether you should now use notebooks in your CI/CD, because when you get a tool which automates the step from a notebook to a pipeline, why not just check the notebook in and let the pipeline produce in the CI/CD? So this sounds nice and can be the future, but not yet. We need more contributions for this. So at the moment, LineaPy saves you time to get from there to there, but you have to check it by hand afterwards, because the Pickle thing, it will always break something, I think. Yeah, but it really helps you to cross the line from dev to ops. And it's not the only feature. So they're working on more features. They're even working on a platform to use LineaPy. And just follow them on LinkedIn, join them on Slack. So there are a lot of things which will happen in the next few months, which I think it's worth to follow. And yeah, you can also think about contributing, because they're really community focused. They're really nice to work with. So it was a pleasure for me to work with Andrew on the code, and I really learned a lot. And well, that's where I think we end now also. I have also to say thank you to the Vogra, which the company I'm working with. They enable me to do contributions during my working time, doing open source thing, and this is really also something very important, I think. A lot of companies use open source, but they don't allow their workers to contribute in their working time, which I think it's a pity, because it's not only a giving, because you also get something back, you get experience back. I just saw different way to work also, because everybody of us has a different style of working, using other packages which you are not aware of. So it was really cool to do this. And yeah, last but not least, I want to thank you to the organization team, because there are a lot of volunteers doing a great job. And also the stuff here on the back side, the camera and the audio. Yeah, so thank you all. I hope I helped you. I hope this helps you in your work, that you're saving a lot in time and nerves using LineaPy.
Thank you so much for your amazing talk. You just shared to us a lot of knowledge and new libraries. Everyone like open source, so I believe a lot of people now are up to trying LineaPy and maybe making some pull requests to help develop the product. So that's cool. And I just want to say that we still have time for questions. We have 5 minutes, which is great. You're perfect in timing. And guys online, you can also write some questions to Slido. We are monitoring, and we'll be asking it here to Thomas. So we have questions.
Yeah. So one of the things about notebooks is that sometimes you. Okay. So one of the things about notebooks is that sometimes you execute a line and then you execute other lines and then re-execute that line before, and that might affect the variable in different ways. How does the tracking of that work with LineaPy?
Yeah, so LineaPy really watches you. It's like a big brother. So when you did a cell execution, it doesn't say, oh, you executed the cell, but you executed the code inside the cell. It remembers it. Even when you deleted it, edited it, or manipulated it, it tracks what you're doing and not what the cell is like. So this is the thing where LineaPy really helps you.
Yes, thanks. I have 2 questions actually. First one is, how does it track these lines? How does it save them and what kind of objects? And the second is, do you I assume it only reads the code in the notebook and it doesn't go a layer deeper, right? So is it possible, if I import my own functions from a Py file, for example, to see those lines also represented?
Okay, so I'm not quite sure, but I will start with the second question, because the first one I just had problems to hear with. So when it's outside the notebook, a library lying outside the notebook, which is not imported by a package management system, I think at the moment it's working not, but I'm not quite sure. So if you join the Slack community, ask the question. I cannot answer. The first one, I just had problems because so many persons were leaving the room. Can you repeat it?
Yeah, these code lines that it tracks and shows you if you request them again in your artifact, how does it save them simply? How does it, is it in external files, or how are they tracked and saved?
Okay. I don't know. Sorry. No, I've not looked inside the really the core of LineaPy, but it's also a good news, because if you want to contribute and implement your own framework, you don't need to know something about how the core of LineaPy is working on. But also here, join the Slack community and ask that question. I even think there is a podcast where Doris and Andrew explained how this is work and the intrinsics work. So it's really join them, ask them, and we will post, I think. You get an answer there.
I was just wondering, how you are using LineaPy. So what is your single source of truth? You told us that you are usually only looking at the generated code because it's easier to understand than the notebook itself.
I will do in future.
Okay, you will do in future. But the question is, if you have this generated code and it's easier to understand, will you ever go back to the notebook? Where do you want to develop further on?
So I got nerfed by notebooks 2 years ago, and I tried not to use them. But I came back, because when you're not using notebooks, as fuzzy as they are, you're missing something. You're missing solutions. And so the notebook, it fulfills so many criteria of the first field of development, iterations, getting feedback, etc. That's really worth using it. But I'm lazy, I don't want to do that boilerplate things and refactoring my notebook. This I want to automate. And this is my use case because I got a lot of small AI projects where I only have 2 weeks time to show results, and this saves me a day or 2 days of work. That's it. And 2 days of work is fine. You can go to the mountains. Another question?
We still have time for one more question.
Just pass it by.
Thank you. Just one, adding to this question actually. So what happens when you have you had run LineaPy to create the output files, and then you do a minor change in the notebook and rerun it? Is it so intelligent, so to say, to kind of bring it in an intelligent way that it doesn't mess up the whole differ story, so to say? Thank you.
I think that's really the point which I mentioned. So will LineaPy allow you to check in the notebook and generate the CI/CD pipeline automatically? So the thing is, when do I switch from a notebook to a pipeline? Then I'm pretty sure that the solution I found won't change much. And afterwards, normally, I'm working on the hyperparameters or doing slightly changes in the code, in the pipeline code. So this is the way I would use it. But in case you want to work in the notebook, back again. So we are in future, what we've talked about, which will be perhaps problematic. I would do a git merge and hope that git just does the things I did afterwards the last time, again on this newly generated notebook. So this would be my hope at the moment, to if you would like to stay at the notebook also for, well, the next 2-3 months of your project. It was a pleasure to be here.